Okay, I'm going to be giving an overview of the XY Utilities package, which is a way to make it more convenient to work with XY data in LabVIEW. So what I mean by XY data is a cluster of an X array and Y array. And we can also have, imagine an array of this cluster, an array of this XY data. So the README on the GitHub has documentation for all the functions and methods provided by this package. I'm going to switch to LabVIEW and give a demonstration. So on the block diagram, I have two data sets, two XY data sets, which I build into an array. And if I run the VI, we can see what this data looks like. So this is just some Y versus X. Now, suppose I want to do the following. I want to add a constant to one of these, and so I'm going to add these changes to a control. So okay, so we add this numeric to this data. We can change it to floating point. Okay, so let's say I want to offset in the Y direction. When I run this, you see what happens is, well, the data like seemingly disappears. That's because this number, first of all, is much bigger than the data that we have, so I can make this smaller. Okay, so that's not bad, but you see what happens is that this basically what LabVIEW is doing is adding this number to both the X and the Y arrays. So you could unbundle this cluster and add the number to the array you want, and then bundle it back up. But the purpose for this this XY Utilities package is just to make that more convenient. So we can drop the add method here, and now you'll notice there's two inputs. Sorry. Two inputs, there's an X and a Y input. So this gives you a choice of which one do you want to add that to. So I chose Y, and now you see the X, it shifted back in the X direction from before. So let's make this number smaller. So 2. So now you can see that that number is only being added to the X array. And we can do a similar operation for the Y array, for the Y array. So now I'm going to show that this VI will also work for an array of data. So I can wire this, and you see this changes. This is a polymorphic VI. So now if I run this, this number will get added to both of the data sets. So I can add a large number to offset both, and so on. So basically there's primitive arithmetic supported: add, subtract, multiply, divide, and square. Let me just demonstrate one more. I'm gonna square this bottom one. And well, this is a very small number, so maybe this is not the best example, but you see here's this is the squared data, and you see it as the exponent doubled. So the square is only operating on the Y array in this case. Okay, so what else do we have? We have a sort, a reverse, decimate, decimate array. Let's look at decimate. Decimate has a decimating factor. We can also average or not average. So let's do decimating factor 1, which basically means no decimation. Let's change this back to a linear. Okay, and let's have a look at the points like this. Turn off loose fit. Okay, so now what I'm going to do is, so that was decimating 1. So now let's do a decimating factor of 10, which should reduce the number of points by a factor of 10 in the red curve. So you see that's basically what happened. We can reduce it more. We can also turn on averaging. Let me go back to 10, and we'll turn averaging on. So that's going to basically take those 10 points that we threw away previously and just average them together. So you can use this as a way to apply some, it's kind of like a low pass filter to your data. Okay, so this decimate function operates on the individual X and Y arrays. So if we go inside this, you can see that we unbundle the X, we unbundle the cluster, decimate the X and the Y arrays the same way, and then bundle it back together. But suppose you wanted to decimate this array, the array of XY clusters. So we can do that. There's a function called decimate array. So this one will operate on an array like this. And this has a control of the decimating factor. So so if I do 1, this would mean no decimation. If I do 2, it's gonna, we only have 2 elements of array of our array. So let's do this. Let's try something a little bit more exotic. So I'm gonna put this array into a loop, and I'm gonna offset each time in the Y direction. We'll just add the index. That'll be fine. Okay, so let's try that. Okay, so this should be basically the number of elements here. Let's turn this number down by a factor of that. Okay. So now, yeah, it's just a little easier to see. So now we ended up with 5 times this. Yeah, that's fine. Actually, let's do this. So I'm going to take one of these clusters. And now we don't need to concatenate that anymore. We can index. Okay, so now we have no. Appears like we're only getting 5 elements. I'm not really sure why that is. Oh, because my decimation was on, didn't realize it. Okay, so so we have 10 here. If I decimate by a factor of 2, then we end up with 5 curves. We can decimate by a factor of 10 and we end up with 1. I can start with 100 and decimate by a factor of 10. We end up with 10. Okay, sorry about that long demonstration there. So so that is decimating this array with a control, being able to control the decimating factor. Yeah, so there's many more functions. Let me, yeah, well, I guess that's it. That's the overview. You can look at, in the examples, there's a tree VI, which basically just demonstrates all of the methods, and it basically shows the analogous LabVIEW primitive. So I already went over add, and then there's square, and there's similar functions for subtract, multiply, and divide. These functions also support adding another, or doing arithmetic on a XY data type. So what this would do is add the Y arrays together or the X arrays as you choose. Okay, and then there's array functions. So you have sort, reverse, decimate, we just demonstrated. There's a subset. The subset, you can choose different methods of choosing the subset. There's 2 methods. One is a slider. So you can take between 0 and 100% of the data, or between 19 and 80%. So that's what those mean. So slider percentage. The other is min and max. And actually, I'll demonstrate that one. If you look at this data, it basically starts here at around 0.01, goes out to 001, back to 0009, and forward. So I'll demonstrate 2 things here. One, there's a get XY, it's this one. And let's put a waveform graph just to show that what I was just describing, so that the X data goes up and down and back to the starting point. So we can take the subset, actually delete all this. So we can take a subset of the data, and if I choose the method slider and put that control on our front panel, and let's look at the output on the XY graph and this waveform graph. So let me change these to be 0 and 100. So that's going to be all the data. I can adjust these sliders, and you see it's basically taking data away from the end, and we can take data away from the beginning. Or we can start at the beginning and just take first part of the data, or the ending part of the data, or so on. Okay, the other method is called min and max. So in this method, what happens is the sub-VI will look at this number and this number and trim the data such that we only have data between this point and this point. So if I do that, you see, and then it also will reorder the data in the end to start at the smaller of those 2 numbers. So let me do that again. So I'm going to switch to the slider method. And you see that this goes up and then we have a decreasing function in the middle, and then it goes back up. But when I choose min and max, it chooses that middle part, but then it sorts the data so that we have an ascending function afterwards. I'm trying to see if there's any others I want to demonstrate in this video. I think this is good. So I hope this was useful, and you please contact me. My contact information is on the GitHub site, way down here at the bottom. Let me know if you have any questions. Thanks.